All right, so let's look at some of the homework from 14.2. We're not going to do a lot of these. In fact, I'm going to flip through to, I think number 9 is the first one. And I started this when I had to redo the video. But on number 9, it's wanting us to determine whether this path described is an Euler path, an Euler circuit, or neither. And so we started at F, we went to B, then down here to A, then E, then D, then C, then let's see. We went from D to C to B, back down to D, and then to A. And so if you notice, this edge here never got touched. So we would say that this path is neither oh, no, not that. Scratch that. The path described is not an Euler circuit or path because not every edge is crossed once. Okay. So let's look at number 10 as well. And you can watch as I highlight this one. We're going to go C. See, we're starting here at C. We're going to B. Then we're going to D. Then we're going to A. Then F. And then B. Uh-oh. Oh, now we're going back to A. And then E. And then D. And C. So I didn't cross over myself, and it looks like I've come back to C. I started at C, came back to C. We didn't hit anything more than once, so that looks like that's a circuit. So it looks like it's both an Euler circuit and an Euler path, but since a path or a circuit is a path, then we're just going to go with the circuit option. So that will be A. It's an Euler circuit because it travels through every edge of the graph once and begins and ends at the same vertex. Okay. See, we got just maybe a couple more. Many of these are very similar. So let's look at number 17. And this one discusses Fleury's algorithm, so I wanted to look at it as well. Fleury's algorithm basically said, let's avoid bridges if we can, and then when we have to deal with bridges, we will. So it wants us to either use Fleury's algorithm or trial and error. But let's see what's going on here. First of all, does it have an Euler circuit, an Euler path but not a circuit, or neither? And remember, that has to do with the degree of each vertices. So I'm going to put a little number next to each. Let's see, this is a 2. What I'm counting is how many lines go to it. So that's 2. A has 2. Let's see, I'll get to D in a second. F also has 2. E has 2. In fact, this thing is kind of symmetric. G has 2, B has 2. But let's look at D. D has 1, 2, 3, 4. All right, so we said in the notes that if a graph has every degree of every vertex is even, then it is an Euler circuit. So that would be A. So now we have to actually do it. Okay, since we're starting at A, and it says to start at A, we're going to start at A, and at this point we can either go to C or we can go to D. Well, if I go to D, then let's see. I guess I could go there, but then I might be worried about crossing a bridge. So I'm going to go from A to C. I'm going to try to avoid crossing the bridge. And I'm going to see what happens. Well, from C, I can only go to F. And from F, I can only go to D. Now, if I were to go back to A, I've completed a circuit and I can't get to this other side. Okay, but if I go to this other side, I can still come back to A. So I'll go from F to D to, I could go to either of those, but let's go to G. Also, we only have certain options here. That is to say there may be more answers, but you could look at what they offer you. Or you could just try to do it on your own, but you might glance at your options as well. But that was A, C, F, D, G, E. Well, we have to come back to A, right? Because it's a circuit. So when I look at these, I have to do either the first one or the third one. Yep, and I guess it all kinds of depends here. I couldn't go from A to F at all, so I could throw that one away. And I could throw the second option away because it doesn't come back to A. And I already knew there was a circuit, so I could have just chosen it that way. We'll find some shortcuts sometimes. I think we only have one or two more we're going to look at. Like I said, usually students don't struggle too much in this section. Okay, let's look at 26. We're going to use Fleury's algorithm again to find an Euler circuit. They want us to start at A, so we got to start at A. All right. We're going to go from, so if we're going to do a Euler circuit, we have to go all the way around and come back to A. We have to end up on A. So let's just map it out first. So I'm going to go A to B. And I guess I could go to E or G, but I kind of don't want to do that yet. So I'm going to go to B. Okay, I don't have an option here. I have to go to H. And I don't have an option here. I have to go to E. Now, at this point, I could go to B or C. Believe what I want to do, trying to make a circuit. So I want to end up back at A. So I got to think about that. I want to hit everything. So let's, let's go to B. And I can't go anywhere except for G. And I want to come back to A. That's what I'm thinking about this whole time. So if I guess I could go to F and go down, but let's go to G to E. And then C, F, G. So I'll write that out for you. We went A, we'll do comma, B, D, H, E, B, G, E, B, G, E, C, F, G, and then back to A. That is using Fleury's algorithm. We have to start at A. There we go. I think that might be the last one. Yeah, I think that's the last. Oh, we'll see. Yeah, I think that's the last one we're going to do. If you have any questions on those, just send me an email and we'll work those. We can work more of those.